So welcome everyone. It's great that I can contribute to DevDotNext in the digital installment. Unfortunately, the normal event couldn't happen, but we all know what's going on. So I'm glad that I can support the event even in this form, even now at 8 p.m. in Poland. So today's topic will be, it might feel a bit like the opposite what's going on conferences around the world, because usually you end up seeing quite a lot of presentations about various technologies, praising them, just asking everyone to marry them, just like Venkat would say. But this one will be like a summary of my recent thoughts after jumping into a few various projects and seeing similar patterns and similar mess in a few of them. So in this one, well, we're speaking about frameworks and the dark side of them. It might feel a bit like it's like a spring rant at some point, but it's not supposed to be. So it has a happy ending. So I hope you will enjoy it. My name is Grzegorz, or simply Greg. I blog at forcomprehension.com and I work at Hazelcast. And I have a question for you. So I don't know if this is something that you have in your country, wherever you are watching this one. But in Poland, we have a show where, which is probably like stolen from some Western country. We have a show where the two groups of people meet, and they are supposed to guess the answers to questions that some random people responded to in some random surveys. And imagine we are doing the same kind of show, but in our IT bubble. So imagine you have two developers meeting at a random conference in the hallway track and speaking to themselves. What questions could they use? I mean, if that's a Java conference, you don't ask usually what language do you use, unless it's Kotlin or something, or one of those fancy ones. But the question that pops up quite a lot, at least on Polish conferences around my place, is that what frameworks do you use? And it's okay, but after being in a few projects out there, it's not one of the first questions I would ask, if I was supposed to interview someone about their projects, and especially if it was very successful. So I remember that long time ago when Spring and Spring Boot was challenging the Java Enterprise. I was in love. I was in love that I could use just one annotation and that would solve pretty much everything. I could have a service up and running in just a few annotations out there. But I remember like 2 years ago, well, a year ago and a half, I read the article about the Micronaut 1.0, and one of the comments resonated with me a lot. So regarding opinionated and unopinionated frameworks, I think they appeal to different types of developers. I now have 20 years of experience, and in my first few years, I loved frameworks like Spring. However, as I gained more experience, I felt I needed a framework's opinion less and less. Now I avoid them. And this resonates with me a lot, because if you play around, if you see tutorials online, if you see short pitches during conferences, this is usually not something that explores in depth the subject itself. Usually this is just a very short, very rushed way of showing how things work, usually stepping exactly through the path, the expected happy path. However, sometimes it can get a bit more difficult if you step out of the path that you are supposed to walk. So now, another question for you. I mean, I'm afraid you might not be able to respond, but there is a picture, quite a famous one. Do you know the author and the title? So Obviously, that Scala programmer confronts Java project that uses Maven, Spring, and Hibernate. Salvador Dali, oil painting, 1946. Of course, that comes from the Twitter prog paintings, and it's hilarious because I see myself in there as this guy on the left with a cross. During my lifetime, I managed to kind of infiltrate multiple bubbles in our community. So I infiltrated not only Java developers, but also Scala environment. And I was able to see how both of those groups, they perceive same things and what solutions are considered default and what are considered evil. And the interesting thing is that those bubbles are totally different. They both can deliver good software, but they have different approach to certain things. And so, for example, you won't find anything like Hibernate in Scala, and somehow they are able to survive without ORMs. And I believe that by infiltrating multiple bubbles, my third-person perspective perception of them allows me to kind of pick the best parts of all of them and deliver better software using those ideas. So going straight to the main topic for today, which is invasive frameworks. And there are multiple definitions of that. So let's try to clarify what do I mean by this. And usually by invasive frameworks, I would say that I mean frameworks that are overly abusive and use a bit too much of magic. And I'm aware that many of you might say right now that there is no magic. Magic doesn't exist. It's just a piece of technology that you don't understand. And I fully agree with that. However, if you compare different technologies, you can see that some of them are relatively more complex than some others. So for example, I believe that for example, aspect-oriented programming aspects are a bit more complex than simple like functional programming-based solutions or like simple design patterns like template method or execute around pattern. That's much easier to write and debug a template method than aspects. So what would I enumerate as magic? So that would be runtime reflection, class path scanning, thread locals, runtime annotation processing, and proxies and AOP in general. And naturally, all those technologies, they have their own place and they solve a lot of problems. But sometimes if we put all of them, mix them, all of them together in a bucket, it might sometimes backfire. What's interesting is that in Java community as well, if you go through like sites of popular frameworks or enterprise solutions, usually they promise you that they will most likely solve a lot of your problems and do stuff instead of you. However, if you jump into Scala ecosystem, it's a bit different. Many libraries, they actually claim the opposite. I mean, we are not a framework. We are just a very specialized toolkit, and do whatever you want with that. And this is quite interesting to observe if you've been to one and the other. What's also quite funny is that, for example, if you have people migrating between those groups. So if Scala developers travel to Java and they see Hibernate, they get really scared. On the other hand, if you have Java developers going straight into Scala world, and seeing not that many annotations, they can get confused. So it can be quite hilarious at times. However, don't get an impression that I'm like glorifying the Scala ecosystem, because they have also quite a lot of, they made some questionable design choices, and it can be messy as well. However, quite a lot of this mess can be attributed to something called like a dependency hell, which usually means just putting way too many dependencies in your project that you actually need. If you have a look at how JVM, how resolves dependencies. What happens if you have multiple same jars on classpath or multiple same versions of the same class on the classpath? And then you have a look at frameworks that actually use classpath scanning and that they can auto-configure certain stuff based on how classpath gets resolved. That gets pretty scary. Actually, since Java 9, we have the JPMS, which kind of solves a lot of those problems. So I really await times when we won't be treating JDK 8 as the default, but we progress beyond that. So one of the good things to remember about when you develop software in general, and I have multiple backgrounds. For the vast majority of my life, I've been developing, let's say, custom enterprise solutions or maintaining in-house solutions that are supposed to be scalable, not only when it comes to performance, but they were also supposed to be scalable when it comes to how many teams are supposed to work on that, and scalable in terms of time, which means they were supposed to survive not only till the deadline in 3 months, but multiple years. So one of the good ideas to keep in mind is that you can actually try to minimize dependencies, especially in the Java world, with the zero dependencies rule being like the ultimate goal, which is of course not always achievable. But I've seen way too many projects where when I could find something like commons or common libraries or core libraries, and those core libraries you would find there a lot of interesting stuff. It was total fun for archaeologists. So you would see some Java enterprise dependencies, Springs, multiple versions, Hibernate, because someone might once need it. The sad part was that once you tried to remove something that actually seemed totally unused, some unrelated stuff in a different part of the project would suddenly break because the dependency wouldn't be there and it would override some other dependency being present in that project and bump its version. That's not fun. However, zero dependencies can be quite hard to achieve and sometimes might not make that even much sense because, for example, you probably don't want to rewrite your own, you don't want to write your own JSON from scratch, or you don't want to parse YAML by yourself. But there are tricks that you can use. So, for example, one of the simple tricks that's suboptimal, but still gives you the kind of zero dependencies feel is the application of shading. So, for example, in Hazelcast, we have pretty much like almost zero obligatory dependencies, and those that are obligatory, we shade them and hide them from the public. What's more, I often see, very, very often, people adding, the whole Guava or whole Apache utils only to use, one static method like is blank on a string from string utils. In this case, you can apply manual shading. You can pretty much copy and paste this piece of a code, well, of course, according to the license and giving proper credit. You can manually put it in your project and avoid extra dependency in your project. The idea is noble, but it can be hard to enforce at times. But luckily, we have stuff like ArcUnit. So you have a tool that actually allows you to enforce certain design architectural decisions in your project. So, for example, I have a few my open source projects on my own, and that works pretty fine because you can enforce all of those decisions pretty much by having a few single unit tests. So, definitely check this one out. Even if you don't go for zero dependencies, or even if you don't try to minimize them, that's something really worth looking at because it basically replaces an architect at times in your projects. Okay, but at least in Poland, it is in the Polish language. Many people kind of use frameworks and libraries, the word, as replacements, but as synonyms. But that's not exactly the same. So the difference between framework and a library is that the framework, it's something that puts work into a frame. In the context of IT and programming, it means usually that you have that the base of your project is a framework, and you kind of let go the control of your classes, of when you instantiate them, when you manage them, you gave it up. You give it all away to the framework itself for you to manage. So a Spring, for example, or Quarkus, it's a good example of that, because at some point in time, you need to say, okay, Spring, you do your stuff, and I'm no longer instantiating my own classes. When it comes to libraries, it's a bit the opposite. It's like your code is in the center, and library is something that you use whenever you want or not. What makes a huge difference is that, for example, imagine you have a project where you really like some feature from Spring, but you at the same time you like this really cool feature from Quarkus and Micronaut. Putting them together can be problematic at times, because usually only one of them wants to own your code. And when it comes to libraries, it's the opposite. Since those are just something that you can plug into your project, you control it. So usually it's not a problem to have multiple libraries in your project. It's perfectly fine to put Hibernate and, let's say, JDBI or something else that acts as that for the sake of persistence. What's interesting is that frameworks exist beyond software. So probably you worked in Agile, as in Scrum especially. Scrum is a form of framework, which says you plan on Mondays, you retro on Fridays, you wake up, you stand up at 10 a.m. and you'll be successful. Well, I'm being sarcastic, but that's oversimplifying. That's how it works. The good thing about this is this: once you meet and you evaluate how it works, and if it doesn't work for you, you say, okay, we are not doing retros on Fridays, but on Thursdays. And we can change that. But it would become problematic if you were not able to do this. And I've seen companies adopting Scrum by the book, and it felt even more rigid than before. So, for example, another types of frameworks is franchises. Imagine you want to open your own Whole Foods or Walmart. It's all going perfectly fine until you actually don't want to change something. They provide you, they give you the business plans. They find a place where you can run your store. They give you logos and everything, even help you with hiring crew. And imagine you want to change the name of the store or colors, let's say, or the color in the McDonald's logo. That's a no-go. And that's an example of frameworks where they can become limiting. So it's very important to understand the trade-offs and consciously opt in or opt out from some of them. So just a few notes about frameworks and some aspects that you have not probably thought about. So a very obvious thing: they take time to learn and update quickly. Our industry is speeding at an insane pace. So those technologies outdate very quickly, and that's okay, because we are making huge progress. But we have a limited time during the day. We have only 24 hours. Well, now, especially when we are all quarantined, it might feel like we have a bit more, but it's still 24. And in order to be very proficient in an opinionated framework, you need to learn framework's opinion. You need to learn how it works. Otherwise, you will be struggling long term. So you need to learn how your properties files are structured. You need to learn how to structure your code. You need to learn where to put annotations, where to skip constructors, and all stuff like that. The problem is that those opinions will change very quickly. And if it changes, you need to kind of relearn all of that. And if you don't spend time on doing this, that's actually where you can be even less productive, because you still keep in mind the old ways of doing things. And another aspect is that once you commit to a certain framework, once you use your domain let your domain classes inherit from some base classes from some framework, and pollute your domain, your domain with all the annotations and methods that were inherited from framework classes, suddenly it's very hard to kind of move away once you figure out that we no longer need this one. There are better alternatives on the market. And if you don't keep up with the release cycle, with the new releases coming over and over, you might not be even able to migrate to the newer version of your framework which you use. And then you probably might need to pay quite a lot of money for someone to backport security and bug fixes for you, which can be expensive. The next thing is that sometimes, I mean, in most cases, if you bring this big, huge solution that's supposed to solve all your problems, it often does, but it also brings quite a lot of stuff that it solves the problem that you don't have and brings a lot of stuff that you don't really use, which can increase the complexity, weight of the project. It can contribute to the long startup time, or they just bigger memory usage than you would expect. Another aspect of frameworks and libraries and the industry going very fast is that they go out of fashion and then get abandoned. So imagine that we now on the market have a few competitors that are trying to, let's say, take over. They are trying to actively take over where Spring is at the moment. And if they successfully do this, you might need to forget what Spring was doing and how they were doing this, because there are new things, there are new frameworks, new libraries with their own opinions and their own ways of doing things. So that's another aspect that you need to take into consideration once you make the conscious choice of opting in or out from certain technology. So the same problem is that you need to keep up with them, and if you end up stepping out of the happy path, you might need some expert help, which is again very expensive. And now, at some point, usually someone points out, this is usually a moment where someone points out the Googles what Hazelcast is. And on Wikipedia, they see that, Greg, but are you doing a framework as well? Well, it's some form of a framework, but not an application framework. So that's just one, two sentences of clarification of what that is. But another thing that people mention usually is the question. So Greg, you don't like frameworks, we get it, but wouldn't you like to focus on real problems and let authors do the boring parts? And yes, of course I'd like to do this, but all non-trivial abstractions to some degree are leaky. And that's an article from 18 years ago by George Polsky. If there was a solution that solves my problems in the way I need them to be solved and the way I would solve them, I would totally opt in. But the problem is that's not usually the case. Usually you need to make trade-offs and you need to accept the parts that you don't like in order to benefit from those that you like. So in some cases, it's worth thinking about, because if the high-level abstractions are leaky, it means that you can't really rely on them, but you still need to understand what's happening underneath those technologies. So with this limited time that you have per day, you still spend time learning someone's abstraction and not the underlying technology. And now it's a question for you. What do you think would be more beneficial for you to learn another set of rules and opinions, or maybe learn the SQL really, really well. This is how we get to the ORMs and JPA and Hibernate, for example, which works really good for certain use cases, but it brings a lot of trouble in the projects I've seen, mostly because people don't understand how JPA works. So if you see the tutorials that are available online, in many cases, you will see that they are oversimplified, and that's okay because those are tutorials. But people often apply those ideas without any afterthought. So what I see quite often is that you take your core domain classes and you put all over them a lot of JP and Hibernate annotations. And well, this is only one class and it was a tutorial, so you also put the Jackson annotations in there because, well, it's a user, you can store it, you can persist it, you can convert it to JSON as well. And this is when it starts to hurt at some point in time. So as long as the model is simple and graspable, and we are on the happy path, that works really cool. But if you take it to an extreme, sometimes it can become, well, really overwhelming. And annotations can actually form some form of meta language inbuilt in your language, which is really hard to track and debug at times. So, for example, if you are looking into ORMs and persistence layer, SQL is great. It's completely self-sufficient. It's fully declarative. But there's a problem, because if you want to, let's say, not use JPA and just use SQL with, I forgot the name of JDBC. There's just a lot of string concatenation. There's just a lot of stitching strings together, which is terrible, let's be honest. But we have tools that solve those problems, only those problems, not all of them. So for example, SQL, the lack of type safety in SQL is solved by Jook, J-O-O-Q, where it doesn't really enforce anything on the application, but you can use it to build your persistence layer or just to generate SQLs. If you are into Kotlin, there's kind of similar idea emerged in there with the Kotlin exposed, which allows you to do the same. You don't need to go for this huge JPA Hibernate project. You have an idiomatic solution, Kotlin exposed, where you, again, effectively, it just lets you write SQL using type-safe builders. And if you are using Spring framework, there's a really cool solution that's not getting enough attention, I believe. And you have access to it pretty much in every Spring project, which is a JDBC template, which makes persistence really, really easy. And this is old and good JDBC, just on steroids, which makes it much easier to use. Without pretty much all the pains of the classic JDBC are gone here. You still might need to manually stitch some strings, but the mapping is really, really easy. So at the end of the day, you write a bit of boilerplate code that allows you to where you take the result set and convert it into an object by hand. Same with when writing inserts. But at the end of the day, that's a very simple code that is really hard to break. And if you opt into Hibernate, you need to understand how it works. You need to understand the dirty checking, where the objects are attached, entities are attached or detached. And it has certain benefits. But when it comes to tracking which objects come from which session, if they are attached or detached, you don't need to worry about all of that. You convert it manually from a result set, you get your object and it's done. You forget about all the problems related to, let's say, those Hibernate proxies circling around your project. So Hibernate naturally has a lot of advantages, but that's a really cool one that I really appreciate. things being simple and not really breaking, like the muscle cars of America and 80s. But here comes the happy part. Frameworks don't need to be that, but they are as invasive as you let them to be. And so, for example, the common issue that I see is that we have one single domain class polluted with JPA, with Jackson, and pretty much all other like solutions that shouldn't really sneak into the domain. And this is often what happens if you have someone relatively junior jumping into your project, someone that read, let's say, Uncle Bob's book, and they notice the application in code. Because you have two classes, you have a user and persisted user. And both user and persisted user, they have the same fields. Well, it's the application, don't repeat yourself, so then you merge it into one. But then you create a very strong coupling. And I believe that the application is a bit better than unwanted coupling. So the very simple way that you can try to keep something, technologies that try to be invasive, if you want to keep them at a distance, don't worry, don't be afraid to create something that looks like the duplication, but it's not. It's an accidental duplication, because the user class comes from a domain and represents something totally different than a persistence model, which is just a piece of infrastructure used for saving your data to a database. Naturally, if you go for greenfield, probably JSON schema and the database schema and the domain class will probably look the same. But over time, probably what you store in a database will drift away, and what you expose outside in public API, for example, through JSON or XML, will probably drift away from the original concept. And this is where you start appreciating that you have separated persistence model from domain, and, for example, from JSON on whatever else. Spring is also a great example of great framework that you can improve the experience of working with just by remembering a few good ideas. So I remember a long time ago, tutorials all around the place. They were praising Spring and annotation-based config because it's so easy. They would normally just put a non-final field into some random class, put an auto-wired annotation on this, and look, it injects and it works. And yes, it works, but even the Spring team long time ago realized that it actually has a problem, that there are trade-offs. It introduces a tight coupling with the framework, and the most sad part is that it forces weak encapsulation and mutability. Because maybe your fields, it's a good idea to keep them non-mutable, but in order for the injection to work when you put an annotation on a field, it needs to be mutable. It can't be final. So already there's a trade-off. You need to give up immutability for the sake of dependency injection. Another thing is there is no clear constructor. So that's not that obvious how you create and how you initialize such class in tests. Imagine you get a class to work with from your friend. In such case, it's not really obvious, because if you instantiate it, you create it using a default constructor, then you need to set the field manually, and then it turns out there's this post-construct method that you need to invoke manually. There's a lot of things to remember, and all those things can be actually encapsulated and exposed through the public API, so that people that consume those classes, they are not burdened with thinking about all of that. So a very simple idea is to opt in constructor-based injection, which is a huge improvement, because now we have a public API for instantiating our classes. So as you can see here, you know that you can create a facade using, and it requires one dependency, which is called the full service. So now, if you want to create an instance of that, you are forced to provide this dependency once you try to instantiate it, which is great. But you still have this post construct method, which you need to call manually, which is non-ideal. So luckily, in the newest versions of strings, since already a few years, you don't really need to put auto wires in your constructor because it can discover it by itself. But we still have this post construct method being called here. There are valid reasons for having post construct methods in your Spring applications, but this is probably not this one. This is a simple method, simple plain method call that does actually not much inside. So in such cases, maybe you don't need the post construct and you can move the instantiation straight to the constructor. And now, once you move this class, you give it someone to play around with. It's not a problem because you instantiate it using the public API and it's ready to use, which is great. But wait, what? It seems like the config disappeared because we have no annotations whatsoever. And this is another really underestimated Spring feature, which is called, well, Java-based configuration, which allows you to keep all the related Spring configuration in one configuration class and manually instantiate all the classes that you actually need, which is really convenient because in this way, you don't make any compromises for the sake of dependency injection framework, but you reuse the public APIs of those classes. So FooService and FooFacade, they both have instantiated manually using public APIs and then registered as beans, which allows to keep Spring in one spot, and it doesn't sneak into domain classes and other ones. So if you want to give up and replace Spring with something else, or not have a dependency injection framework at all, you just drop that class, and that's all. You can start wiring it up again by yourself. Another idea is that sometimes it might be even easier. You don't need to register all the classes as beans. Of course, there are valid scenarios if you want the magic transactions and proxy metrics and the proxy magic to work. You need to do this. But if you have a simple services, simple plain Java classes that don't rely on this kind of magic, remember that you can just instantiate it by yourself straight and not register it as beans. Spring will have a bit of less work to do as well. So we arrived to the conclusion where we have the same framework used in an invasive and not so invasive way. And the bad news is that it's up to us to figure out the ways of doing this in a non-invasive way. That's not a universal concept that you can apply to all the frameworks. It's up to us to analyze how they look like, how they work, what are their ups and downs, where are the trade-offs, and up to us to try to minimize the impact in order to get long-term maintainability. Naturally, maybe your context is different. Maybe your project is supposed to be shipped in 3 months and someone else will be maintaining it. Then you have different contexts and different choices to be made. Another thing that I really like to use is that instead of magical annotation, quite a lot of stuff can be replaced using a composition and simple delegation. So, for example, imagine that you want to apply caching to your to some of your classes, or imagine you want to configure interceptors or anything like this, like in Axon. That's something that you don't really need to do using annotations. It's not really a lot of code to write if you don't want to use that at all. So, for example, introducing caching to your, let's say, user session repository is just implementing the same interface, putting the original implementation in there, just caching it manually. The cool part about this is that if you want to test all of that, you don't need to wire some magical framework that will wire up all the context. It's all available just for unit testing because it's you who control the caching, not some annotation processor that needs to interpret the caching annotations on your classes. If you ever heard about hexagonal or clean architecture, those are kind of very, very similar concepts, just advocated by two different people. hexagonal architecture is it's a bit not it's a bit theoretical idea of writing your applications in such a way that in the center of your systems there is a domain, which is framework and library-less, which is just a clean code representing the pure domain. But this domain exposes certain plugs outside where you can easily plug in your persistence, HTTP clients, and whatever else is replaceable. Why I'm saying it's theoretical? Because it's really, really hard to write a whole system in a pure hexagonal manner. But it's a very useful idea to keep in mind, to remember about once designing your systems. So I have one story to tell you about playing with Axon, RabbitMQ, and Kafka. A lot of this information might be, by the way, outdated because it's a story from the Axon 2 times, and now it's Axon 4. But it works really fine. So in one of the previous companies I worked for, we had a really huge system consisting of over 150 services. And after some time, we figured out that RabbitMQ as a communication medium doesn't really scale that well for us because there was a lot of traffic going through. And since the system was event sourced and utilized CQRS a lot, so there was a lot of events circling around the system. It turned out that the RabbitMQ is a potential problem. It's a potential single point of failure. And we try to do something with that. At that point in time, we're considering going into Kafka or something else. And adoption of a certain framework allowed us to write a very easy way of handling certain events from RabbitMQ. So our thought was, okay, so let's just get the Axon Kafka module and make it and try it out with Kafka. So we go to the Axon repository, and this is where the surprise comes in. There is no Axon Kafka module. I mean, there was not at this time. There is not. It exists now, naturally. And now we have a problem because our system was based on Axon. There were many services communicating through Axon, which treats RabbitMQ as the first-class citizen. And there is no way you can kind of opt in and plug in whatever else you wanted at that time. So we had a few choices, either to run away from Axon, but it wasn't really feasible to run away from 100 services that used Axon. Another option was to actually try to contribute to Axon and contribute to the new Axon Kafka module. And this is how it ended up with one of our engineers actually contributing the Axon Kafka module, working for a few months on that. At the end of the day, we never managed to migrate to Kafka. Well, maybe they did. I don't know anymore. I don't know at this point in time. But the work spent on the Axon Kafka module was significant. It was a few months of work. But at some point in time, we decided to take a different approach and managed to solve the problem in, I think, under 6 hours. And the idea was to actually not rely on the framework. And I want to show you that it's not that much work as you might expect. So, for example, if you want to handle events coming through the RabbitMQ broker, that's very easy because this a lot of stuff gets auto-configured, and then you put an event handler annotation on your methods, and it pretty much magically routes the events to appropriate methods. So if you receive a session started event, you can expect this method to be called whenever the event is received. As simple as that. But let's see how much work would need to be done in order to actually have the same functionality done, but without the framework itself. So I can imagine that an event handler underneath, somewhere in there, somewhere in internals, it's effectively just a map. It's a map that can route to different methods depending on something coming from a message. So let's create an interface that returns the routing configuration. That's not very difficult. Then you can create your own routing configuration, which is a bit verbose because you need to manually provide the types of those class, unfortunately, because that's how Java works. But it's not a big of a hassle. And you can test all of that very quickly because you don't need a huge application context running in your background for the integration tests to kick in. You can test it unit test very, very super fast. Okay, that works. And the whole routing logic is effectively just checking if receiving a message, and once the message is received, you check if the route is in the configuration. If yes, you call the method. If not, you don't. That's pretty much all. And once we made it work, now we could implement a very simple Kafka event listener, which would just read messages from Kafka and pass the messages straight to our event listener, which was generic. Same you could do for RabbitMQ. A bit more code, but at the end of the day, it's just something that receives a message by yourself and uses the same infrastructure here to route the message. And that's pretty much all. And the cool part of that is that using multiple Spring profiles, we could have it running alongside. So we knew that we made it work. It worked in a below 1 day, but we knew that we won't migrate that fast to Kafka. So we had 2 Spring profiles where we could switch in between very easily. So once the Kafka is there, we switch the profile and it works. I hope it happens one day. However, it wasn't a lot of work, but from the point of view of long-term maintenance, it's a huge upgrade because we were able to kind of bypass the problems imposed by the framework pretty much by writing not that much of our own code. Obviously, that's a kind of a hacky solution to the problem that long time ago, when the technical decision was made to use one particular framework, no one actually had a look at trade-offs involved in that and how this would fit in that particular context. So we are slowly approaching the end of what I will try to show you. But at the very end, I'd like to tell you first that although it might have sounded a bit like a Spring rant, it wasn't. So I still use Spring pretty much in all my projects because it works really great if you actually know a few good practices on how to work with that. Plus, Spring doesn't really own the architecture of your system. So even if you mess it up, and even if you have microservices done the right way, it impacts only one service, not all of it. So that's okay, because that's one of the main values propositions of microservices, that if something goes wrong, you can rewrite quickly. So I still use Spring pretty much in most of my projects, although at times I have love-hate relationship with it. But if you are reaching the end, I'd like to at least pitch some other tools that you could try. So, for example, if you would like to try something unopinionated, you could try Ratpack, which is like a collection of Java libraries for building very scalable applications. And again, it's not a huge platform that solves all your problems. It's kind of rather verbose and doesn't really jumping onto convention over configuration train. So you can configure things by yourself, pretty much. It's really good for very small applications. I can imagine being a bit more tedious for very big ones. However, if it's too much code for you to write, it has a very cool, groovy DSL to work with, so it gets a bit much better. Another thing, which I really like recently, if you want to try more opinionated stuff, that's Quarkus, which is, since it's written pretty much from scratch, it doesn't really need to adhere to any backwards compatibility or legacy choices. It works really great with containers and leverages the power of GraalVM. And for me, as a developer of a Hazelcast client extension, that was a blast to work with. because even for developers got a really nice framework for working with GraalVM, which is great, a really great experience. But at the very last moment, I'd like to remind you that the ultimate best practice is common sense. So make conscious choices, be aware of your context, be aware of trade-offs, and pick whatever you need for this particular context. And at the end of the day, usually customers don't care if you wrote the library, if you wrote the code by yourself, or if you use the library that does all the stuff for you. If it works, it works. And at the very end, I'd like to show you this article by Toński. And that's a bit kind of an angry rant about the state of our industry, which is it's an interesting food for thought. So thank you very much. This is what I wanted to show you. I hope some of those ideas resonated with you. I hope that some others gave you some food for thought as well. And thank you very much. And you can find me on Twitter, you can find my blog, and let's see if we have some questions. So thank you.
Well, thank you. Really, that was exciting to hear. I was almost on the edge of my seat listening to some of the things you said, almost like an action thriller, if you will. So thank you, Grzegorz, for taking the time to talk. I have a few questions here from the audience, so I'll read them out to you. The first one is how to get domain code free of framework when you use reactive framework as Spring Web Flux, where you need to return Flux and Mono.
It's not really, it shouldn't be really that problematic, because if you return, it doesn't matter if you return Flux, Mono, Eric's Java, or if this is proxies from Hibernate. At the end of the day, if you read on domain-driven design, it's possible to make the core of your project frameworkless. However, you will have those frameworks being on the side of the project. So you will probably have some code responsible for processing, being fully reactive from, let's say, somewhere on the persistent side or on the neck close to the web flux. You can keep it a bit away if you want. On the other hand, however, if you want to be fully reactive, from the top to bottom, this is the moment where you need to make a trade-off, most likely, because this is the part where it could become a bit of difficult. If you really wanted to have this full like reactive flow, and without cutting it somewhere in the middle. So this is the problem that I can see, and this could be potentially hard to avoid. But if you are not fully reactive from top to bottom, that you can easily avoid by keeping the infrastructure for reading from databases and, let's say, web flux just on the side of it. So when it comes to with the web flux, the way I often do, or what I try to do, is that the public API of my, I don't keep much code in controllers. I try to expose one huge facade exposing public APIs of my domain class. And now the integration exposure, those API methods are exposed through web controllers. This way, I keep most of my logic inside the domain, but only expose what I need through the web controllers. So this is usually just delegation. It's just each controller is just calling one method and deserializing incoming data and passing it through to there.
All right, I'll read the next one here. Would you rather have familiarity over framework control?
Familiarity, depends, because if you look at the grand scheme of things, if I have an absolute familiarity of one certain tool, that's great, because I can be super productive in that. On the other hand, as I said before, the tools change, the tools evolve. Sometimes you might jump into other tools, and having all the familiarity with all the tools out there and the versions keeping up, that's a big utopic vision to have. So usually I try to strike the balance. I try to find the right balance. So I know personally that I probably benefit more from spending time on learning, for example, the basics of distributed systems. But in order to be able, when I keep my framework knowledge usually to a place where I have enough knowledge to know what I don't know, so that I can check it and then to be aware what to check when the versions change. So this is pretty much my take on this. I try to invest in the basic and universal knowledge, which kind of helps me in multiple areas. But when it comes to frameworks, I learn enough to know what I don't know, which allows me to navigate easily and just read up on stuff whenever I need something to know better.
Cool. Did you measure performance between Spring invasive over manual configuration and minimum interaction from Spring?
No, I didn't. No, I didn't. But there is some really good article about Spring performance. And improving startup times and all of that stuff. I don't remember who wrote it. Ask Josh in a few minutes. I remember it's out there, and pretty much, making it startup faster means turning off auto configuration, some of the magic, and all that stuff. So I didn't, but I expect that the more magic you turn off, the faster it will start. But when it comes to the raw application performance, if you have a look, for example, how fast requests are processed, I wouldn't expect to see a lot of difference here, because that's probably just a few extra classes, a few extra, let's say, allocations on startup, and maybe delegation for a few extra method calls. So that's not relatively. It's not relatively expensive in this context. So I'm not sure if this answers what you wanted to hear, but
yeah. So this also is a question from the same person, George. What about jar exclusions? If I don't need them, I will remove them. How much difference are we talking about using Spring Boot starter versus adding dependency manually into a project?
What kind of difference? The question from my side, what kind of difference do you want? You mean performance difference? Or usually it's a good practice to exclude stuff that you don't need. In such case, for example, I remember long time ago in one project, we went live onto production with H2 on, because it was one extra. We had the mess with dependencies, and it turned out that auto configuration kicked in and configured the in-memory H2, which went on production. Nothing bad happened, but usually it's a good idea to keep stuff that you don't need away, especially if you deal with frameworks that scan your class path and do decisions based on what's on your class path.
Yeah, he says both from the point of view of size and performance. So I'm assuming performance absolutely is critical no matter where we are. I'm assuming size is a concern depending on where we deploy and how we use the application.
So it can affect size, and it can affect the size of a jar, of your fat jar, both, and the memory that it uses at runtime. Because if the framework auto configures, if it scans the class path, if it sees certain classes, it auto configures something based on this. It needs to load these classes, and let's say maintain them in the context. So so you can expect some not that significant change in memory usage, because you would use a bit more of that. So I wouldn't really worry about this. I wouldn't really worry about jar size. You could get some extra boost on startup if you just exclude stuff that you don't need, so it doesn't need to be configured. But the main benefit is, in this case, I believe, is avoiding mess than performance or memory optimization.
Well, Grzegorz, it's late evening for you, so I really appreciate you taking the time for spending with us and educating us and making us think a little bit further about how we bring in dependencies. I really thank you. I'm going to hand it back to Sharat.
Remember about social distancing when working with your frameworks.